So I sometimes tell people that for me, this is a little bit like being an eco-tourist in a miniature Alice in Wonderland. Because I just look at this and I just think it's a wonderful nature walk, even before you do any other type of research on the system. Well, there are different ways of looking at these microbes by light microscopy. We have, with this microscope, the capacity to do dark field microscopy, where cells will appear white or be outlined in white with a dark background. We can do phase contrast microscopy, where cells or edges of cells will be dark on a gray background. We can do regular light microscopy, where you don't see much of anything unless the sample is colored, but you'll get the real color of the sample. So if your sample is green or red, you may actually see that in the cells. We also have the capacity to do something called DIC microscopy, so difference, interference, contrast, which, as opposed to giving you contrast in terms of either white and black or sort of dark and gray, it gives you more of a lunar landscape type of edge contrast, in the sense of you look at the moon with binoculars and it's all gray, but you will, when you focus it, you'll start to see edges very nicely. So I've set this right now to look at the sample using this DIC. What that does, it gives you surface textures of cells and internal structures of cells, if they're large and if they have those structures, much more cleanly. Whereas under a different type of microscopy, the whole cell may appear gray on a light background or white on a black background. Here you'll start to see textures on the actual cell or within the actual cell itself. And for many of the protozoa that we have, the larger eukaryotes that we have, that will allow you to see not only internal structures in the cell, but also perhaps particles of wood. And so here, right now, we're looking at two gut protozoa. These belong to the genus Trichomatopsis. These are cellulose degrading protozoa. And right now, with this one that's sitting right in the center here, I can adjust this a little bit to bring out some of this edge contrast. It's a little bit hit or miss. Okay. Oh, this is looking gorgeous. For instance, this is one of these very large Trichomonas-related protozoans, and it's starting to bleb out. It's starting to get ill. And that's what some of these little blebs out the side are. You can use this DIC to really get an optical section. So I'm just going to go in from the surface. You start to see the surface come into focus. It looks like it's covered in these long lines, long grooves. And now I'm going into the cell, and now I'm going through the other side. And it allows you, if you do this on the posterior of the cell, you can see the nucleus. So I'm coming up, I'm looking at the surface, now I see the nucleus, and now I start to see the other side. What I can do is I can compare phase contrast. Looks good. This is this edge contrast. It also looks good. And it's just a matter of taste. And for some of the thinner cells, this phase contrast looks better. Actually, we see two protozoa here. One is this one in the center with these little frills, and the other one which looks like a bundle of sticks. And this really brings out, this DIC imaging really brings that out. And there are some adjustments you can make. It's a little bit like cooking. You can do it to taste, which is you look at your sample and you just make the adjustments to just bring out in that particular sample some of the textures of the cells. It's almost empirically determined. So now I'm just going to try and find a few other objects worth looking at. This is looking on dark field now, where the biological material appears bright white on a black background. Here we see large trichonympha with these smaller Fascist Protozoan, Streptomastic strix, are zooming in around the looking like slender little almost worms which are shooting around these larger cells. So those are the smaller protozoa. So there are quite a few different species of protozoa that you find in this environment that are different sizes. You have these very large trichonympha. You have these medium-sized trichomatopsis. And then you have these very long, thin, slender bacteria-coated streptomastic strix. So we can see some of these trichomatopsis and streptomastics. Streptomastic strix is the bundle of sticks. Trichomatopsis is this beautiful little organism with these little frills that run around the cell very quickly. And the larger trichonympha. This is trichomatopsis. This is the only termite gut protozoan that's ever been cultured and studied in vitro. And about 3 or 4 papers on this protozoan 20 years ago, and then the culture was lost, and no one has ever been able to culture it again. But this studies on this organism established that protozoa will ferment cellulose and xylan, which are the pentose and hexose polymers in wood, and produce as products acetate, hydrogen, and CO2. I'm just going to zoom around a little bit. So you got some of these spirochetes. There's a nice DIC image of a spirochete right there in the center. And you can see its coils, nice regular coils. Oh, it's still alive, but some of these have been damaged a little bit by the oxygen. Many of these organisms are poisoned by oxygen. Sometimes you make wet mounts and they work out, and sometimes they don't. But actually, this one's a real beaut. I'm just going to look at this protozoan here. There are 2 or 3 of them here. They're these long, slender protozoa that look as if they're striped. And you really see that with the DIC when you look at them. And I always say they're fascist protozoa. And what do I mean by that? You know, the Latin term fasces is the word that describes this bundle of sticks on the back of a dime. And it's the word that really also it describes e pluribus unum. You know, in many there's one. And this I call the fascist protozoan because the protozoan itself is actually exceedingly thin, and the very little that we know about it, studies have shown that this protozoan is covered with a coat of thin bacteria, long slender bacteria. So it's a long stick-like protozoan, eukaryote, that's covered with a coat of long hair-like bacteria. Here you see some of these hairs are actually starting to fray a little bit and come off of it, but you'll see a lot of these, and functionally we have no idea what they do. So this is an example of what's nice to look at. It's inspiring in the sense of it tells me there are a lot of these protozoans in here. We can look at the phylogeny of the host and the cells. We know what the protozoan is, and we know what the species that attach to it, but we don't know what either the protozoan or those bacteria do. What is their physiology? What do they eat? What do they make? How do they interact with the other microbes? How do these products impact the other microbes or the host? And so we functionally don't know where they fit into the puzzle. Presumably, all the cells that we're seeing here that are abundant are symbionts engaged in the mutualism. That is, they're beneficial microbes that really are giving something to the system and or to the host. But in this case, the devil's in the details, and we actually can't say with any certainty, and I actually don't have a real hypothesis about what those organisms do.
I mean, it's interesting because the fascist protozoan are covered in bacteria themselves. So it's like symbiosis upon layers.
And whereas some of the other protozoa, you can see that they've engulfed wood particles into the cytoplasm or into the cell, there's no evidence that they're engulfing wood particles. So it's not, you can't even really say, oh, they're degrading wood. I don't know that they're degrading wood at all. And more possibly, they're positioning these bacteria somewhere in the gut so the bacteria can do something and perhaps feed the protozoan. Examples of other symbiosis within symbiosis. If we look at this trichonympha, this larger protozoan that we're looking at here is sort of a squashed trichonympha. And we can see that it has these long striations that go from anterior to posterior. But if we look a little bit more closely, we'll see these little, towards the front end of it, these little black dots. Those are also bacteria. And this protozoan has both ecto and endosymbionts. It is covered with a layer of bacteria on its surface, but also it contains bacteria inside the cell. And again, we don't have any understanding of what the physiology of those bacteria on the surface or on the inside are. We have some sense that these protozoa ferment cellulose and xylan, but we don't know where these bacteria fit into the picture. So we're missing something fundamental. So I love this system because there's lots of diversity and there's lots of action. And we've learned a lot, but actually I think we know much less than we know more.